Good afternoon, ladies and gentlemen. Good evening. Welcome to another series of tutorials with me, Aubrey. In this lesson, we continue with Math 310, which is calculus. All right, and specifically, we'll be looking at line integration, all right, or linear integration. Which is a different linear integration from the Math 410 linear integration, because in Math 410 we have 2 dimensions, and for this one we only have 1 dimension. Okay, basically the idea is the same. Math 310 and Math 410, you are integrating over the curve. We are going to call that curve C. We can give it the name maybe mu, like that, but it can be either. So that curve, we're calling it C, and we're integrating over that. Okay, now the idea is that the integral should be made to conform to this curve. All right, in linear integration, you try to make the integral to conform to the given curve of integration. Let's look at an example to better understand this. So let's say example, evaluate. Okay, you're asked to evaluate integral of 2xy. Let me put it here. Evaluate integral of 2xy dx plus 2y dy. Okay, let me do this. 2y plus x dy along y is equals to 2x. Okay, where the curve C is the line, where the curve C is the line this, so C is the line this. If you see whatever letter you see there, the letter there is just representing the curve we are integrating on, and we are integrating on from 0, 0 to 1, 2. Okay, so let's evaluate that. So remember what we said. The integral should conform to the given line of integration, and what we mean basically is we're going to use the line of integration to make everything uniform in this integral. If we have dx here, dx meaning that everything here should be x. We have dy here, meaning that everything here should be y. Okay, if you have dx, again everything here should be x, dy, everything here should be y. And how you can manipulate such that everything here is x, you use the line of integration. Okay, remember you also have limits. I'm going to teach you how to place the limits. So where there is we want this to go out, so we just replace y with 2x, so that we have the line integral of 2x times 2x. Okay, we've replaced y with 2x, then we have our dx here, plus, remember we want everything here to be y, so here we need to make this to be y. How we can make y? We can use this equation. We make x subject, so x will actually be equal to y over 2. So now the equation now becomes 2y plus, where there is x, we're replacing y over 2, so we have a y over 2, then dy. Now here is a very important thing that you need to note. Alright, on the limits of integration, where there is dx, you use the x limits, which is this comma that, the starting point, ending point for x. Okay, so meaning that we need to do this. So let me just move this. Okay, we can separate the integrals like that. All right, where there is dx, we need to use the limits for x. These are the limits for x. This will be your x1, x2. Starting point x1 starts at 0, just say 0, and ends at 1. Then here, where there is dy, you use the limits for y, which is 0 to 2, so y starts from 0 to 2, like that. Okay, so from here, we integrate this side with respect to x, that side with respect to y. So this side, first of all, let's simplify it. So this is integral from 0 to 1 over 4x x squared dy, plus here we're integrating from 0 to 2, then we say we're just rewriting 2y plus y over 2 dy. So now we can now integrate. So integrating this part will give us 4x to the power 3 over 3. Then we're replacing in limits from 0 to 1 plus. Integrating this part will give us y squared over 2, and these two will cancel out, so it'll be plus again here y squared over 4. Okay, and here we are putting in limits from 0 to 2. Okay, so now here we see that this can be written as 4. Okay, when we replace the upper limits, that will be 4, then 1 to the power 3 over 3. When we replace the lower limits here, everything will be 0, so there is no need to show that, plus. Replacing the upper limits in here, we're going to have 2 to the power 2 plus 2 to the power 2 over 4. Okay, replacing the lower limits here, we're going to have 0 again, so no need to show that. So now we can further simplify this as 4 over 3 plus 4 plus 1, right? Which will be equal to 4 plus 15 over 3. Simplifying everything, it'll be 4 plus 15 over 3, which is 19 over 3 as our final answer. Alright, so basically this is how you compute line integral questions. Okay, but there will be three categories of questions. The first category is where we have dx and dy. The second category is where we have ds, and the third category is where we have dr. Alright, the third category and the second category is where we need to learn parameterization, but where we have dx, like here dx and dy, we just replace y in the equation so that on one side it is uniform and on the other side it's uniform, then we integrate respectively. Alright, so that's it for today's lesson. See you in the next one.